Can you hear? Oh, wait a minute a second. Plug in the... Okay. Excuse me. Come on. Sorry about that. Taking a little while to plug in the power. Okay, we're good. So the point P here in the figure 3, it has the coordinate in x. The value is that is A, right? A is this point. And the value in the y direction is, what is it? What is the y coordinate of the point P? Yes. And the, okay, in order to find the, and the z coordinate of the point P is C, right? How can we find it in the coordinate Z, the OZ axis? Remember, before doing that, we need to find the plane containing the origin and the projection point of P to the OXZ, OXY, XY plane. So from this point, we draw a parallel line, which parallel to the green line below here, right? Wherever it cut the z-axis, this should be the position of the point C. Okay? It's not difficult, just imagine a little more. So here are some examples. If we drop a perpendicular from P to the XY plane, we get the point Q. For example, here, we got the point Q here, right? Can you see it? Okay, this is a projection. When we draw a perpendicular line to the plane, it is called a projection. And this Q has the coordinate, the same coordinate as X coordinate and Y coordinate of P. And in the Z coordinate, it is simply 0. So do you see the projection here? Okay. So, and similarly, if we're given the point -4, 3, and -5, let us find the position of this in the coordinate. Okay, the coordinate here, 0 is this point, x direction is this, y is in this direction, and z direction is this. X coordinate is -4, so it is should be here, right? And in y coordinate, it has a positive number, which is 3. So this is the point 3. And in the z direction, it has a negative value, so it goes the opposite sign direction of the z here. So this is -5. So this is the point we are talking about, okay? So I believe that you can do it well. Do you have any question about this coordinate? Yeah, just something new. Just okay, very good. Okay, here, the space in 3D space, we call it three-dimensional regular coordinate system. And furthermore, there are for 8 octants. Okay. Okay. The first octant is the octant of x, y, and z are all positive. And yeah, you look at the book and study these in the book. Okay. What is it? The names of that, the definition. Basically, we mentioned all of these already. So let us continue. Okay. The surfaces in R3, R3. This is yeah. So now, suppose we are looking for the surface. Z is equal to 3. The surface is the collection of the points here, which has the y coordinate is equal to 3. We don't care about the x and y coordinate, right? Just care about the z coordinate. So, and suppose the coordinate is given like this, then the plane z is equal to 3 is this plane, okay? Because any point on this plane, suppose it here, no matter what values of x and y, they have the same z coordinate, right? We project from this point. So look at this line, the red line here. Is it parallel or perpendicular or something with the OZ axis? Yeah, perpendicular to the red line here. Let us call it T. Okay, it is a projection here. In 3D, it looks not really a right angle, but we understand, right? Just imagine a little further. Okay, similar story. So if here, the equation z is equal to 3 represent the set of all the points in the coordinate whose z coordinate is equal to 3. And similar story, the surface y is equal to 5 here is the collections of the point in the coordinate x, y, z, where y is equal to 5, right? And here is the plane y is equal to 5. Okay, that's the new concept. Do you have any question about this new concept? Okay, seems to be easy for you. Let us continue. And the last things we want to talk about is the distance in spheres. Okay, remember, in 2D, we have the distance between, suppose the point A has the coordinate x1, y1 in 2D. And the point B has the coordinate x2, y2. So the distance between A and B, do you remember the formula of this? Can you tell me? Thank you. Very good. So now in 3D, we just have one more terms here, right? Okay. This is to compute the distance of 2 points in 3D. Okay. You have any question up to this point? Okay. Then here. Okay. Take a look at this example. Find an equation of a sphere with the radius is r and the center is the point C, H, K, L. Okay. This is the sphere, right? In the coordinate. So how can we find the equation of a sphere in 3D? Any suggestion? A sphere is all the points, and the distance from that point to the center will be the same, right? Will be r. So which formula should we use to write down the equation? Thank you. That's perfect. So here we know the formula of the distance of 2 points, right? And here the sphere, suppose P is any point belonging to that sphere, and the P coordinate is x, y, and z. It could be anything, just x, y, and z. Okay. H, K, L is given. So from the distance formula, we know that the distance from P to C should be the same as, should be R here, right? Furthermore, the distance from P to C is square root of, so the distance from P to C, let us write it explicitly here. We call it this way. Okay, square root of the x coordinate of P. What is it? Yes, minus. Very good. And thank you. And yes. Very good. So this is the distance formula, right? And we know that it should be equal to R. So now, if we square both sides, the equation holds true, right? So therefore, we found this equation, right? We call it the equation of the sphere, the 3D. Okay? Are we good? People on Zoom, do you have any question about the equation here, or is it fine with you? Yes. Oh yeah, because we just want to get rid of the radical sign and make it simpler here. It's similar to the, yes, Alu. I'm sorry. Okay. So in general, if this is the general equation of a sphere, right? If the sphere is centered at the origin, right? It means H, K, and L are all zero. Then we have a specific case, as a very special case. Okay, x squared, y squared plus z squared is equal to r. Okay, this is all about the section 12.1. So this week, do you have any question about this? We can do some more example. Okay, very good. Now, how about let us find a circle, right? How about this? Look at this. X squared plus y squared is equal to 1. Okay. Do you remember what it is? The equation here? In 2D, what is it? Yes, it is a circle, right? Thank you. Who was that? Your name is, again, please. What is your name again? Logan, thank you. And Alu, thank you. Okay, so in 2D, it is simply a circle. How about in 3D? How does it look like? It's not, I think it's better to draw it myself. So this is 1, right? But in 3D, it's a little bit harder. Suppose this is x-axis, this is y-axis, this is z-axis, right? So this is in 2D. This guy, we're trying to draw this guy in 3D. How does it look like? So suppose this is 1 in the y coordinate. This is 1 in the x coordinate. So suppose this is the circle we're drawing on the left here, right? Oh, yeah, it's a Z. Thank you. Thank you, Wally. It's a good correction. Yeah, sometimes we talk something and write something else. Okay. So this is, thank you. Yeah, and thank you, Dr. Oxley. And here, this is the circle. It's simply, it looks really not a circle. It's like an ellipse, right? So how about the circle, a similar one, on top of the red one? But the center here, suppose it is at 3. Okay. Does the green circle satisfy the equation here? Yes. So how about the circle, the blue one here at the point, let us say -5. Does it satisfy the equation here? Yes. So therefore, we see that there is not really a good draw that connect all these. The equation of this equation will be the cylinders, right? With the radius is 1 here. And makes sense because in this equation, the z variables disappear. It means that any point here satisfying this equation does not depends on the y coordinate, right? So this is how it looks like in 3D. A little different, right? Just be careful. Very good. So, do you have any question? Yeah, so in this chapter, we need to imagine a little more. Okay. I think this chapter we are, yeah, we just 7.12.1, we just introduced some of these. Let us deal with some more practice problems. Okay, now let us do this example. Try to master our skill computing the distance formula. Suppose we are given the point P 2, -1, 7, and the point Q 1, -3, and 5 here. Okay, find the distance between P and Q. So everyone take a draft paper and compute it yourself using the formula, and we will compare the solution. Okay, people on Zoom, do the same things at home. Memorize the formula, get used to it, just do it. Okay, you done? Very good. Two, -1, 7. 1, -3, and 5. Sorry. Okay, should write it better. Okay, number 5. Okay, now if you're done, let us do it together. Suppose we call this one is the first point, right? P is the first point. Q is the second point here. So the values we substitute in the formula here, what are they? What should we do? Yes, continue. 2 minus 1 and yes, negative of -1, right? Sorry? Oh, yeah. I see what you mean. Oh, my bad. Yeah. 1 minus 2. It doesn't matter, right? That is what I want to do. I want to discuss here. Yeah, okay. 1 minus 2, -3, plus 1. Yeah, be careful. So it becomes plus 1. Very good. And here it will be 5 minus 7. That is my notation, right? If I, yeah, or it is the same as this one. In your point of view, you may call it, okay, this one is the P is the second point, right? Q is the first point. Then it could be 2 minus 1 squared plus, yes, negative 1 plus 3. Or the last one will be, yeah. What I want to say here is it doesn't matter which one is the number first and which one is the second. They will give you the same result, okay? Because here it is a perfect square. So if we change the sign of two things at the same time, it will remain the same, okay? Then finally, it will be, what is it? 1 square, simply 1, right? And here, very good. Yes. And in the end, it will be, yes, very good, good, fast. Okay, very good. So this chapter is nothing new, just some remember the distant formula and go home, review. So, you know, tomorrow we will take the 7.3, right? Review the section 7.1 and 7.2, do more practice problems. Okay, it gives you a little more time to master the skill. You have a good one. You want us to turn in our, yeah, turn it in here. I'll count your class participation based on your work. Thank you. Thank
Mr. Tran, do we email these to you?
I'm sorry, I cannot hear you. Can you repeat it?
I asked, do we email you our quiz that we did today?
Yeah, just try to work on that and email me. It's fine.
Yes, sir.
Yeah.
Thank you.
Thank you. Take care.
Thank you.
Yeah.
Have a good day.
You too. Bye bye.
Bye.
Mr. Tran,
Yes.
you said there was a quiz tomorrow?
Yeah, basically, I will not announce that in class, but maybe we normally have a small quiz at the beginning of the class, so that yeah, I'll count that for class participation.
Oh, all right. And I can just email today's quiz, right?
Yeah, today is okay, but next time I expect you to be in class because yeah.
All right.
What's your email?
My email, you can go to the syllabus, or you go to Moodle's user of the class. You see all the friends in the class. Okay. Yes, Dr. Oxley.
Yeah. How are you doing?
I'm sorry, I cannot volume up.
Can you hear me now?
Yes, I can hear you, but very, yeah, it's not very loud.
Okay. What's the picture behind you? What's the background?
Oh, it's a Sơn Dong cave, the biggest cave in the world, and it is in Vietnam.
Okay. Oh, you've got your recording still on. Do you want to stop your recording?
Oh, really?
Yep.
Oh,